In this video, I'm going to talk about a solution to the red and black cart challenge. That is the one where we have two carts, a red cart and a black cart, and we send them down the track together, and we have to predict where they will collide. Now, the data that I gave you was the ability to watch them in front of the motion detector, and that allowed you to grab from the black cart's motion graph, position time graph, that allowed you to grab the slope, which, as you know, is equal to the velocity. And so for the black cart, we can use 0.125 meters per second. And here, for the red cart, the slope was 0.426 meters per second. All right. Now, those are the velocities as run, but of course, when we actually do the challenge, the carts will be coming at each other. So the graphs will look like, the graph is going to look like, there's the axes, and then we have the red cart, which is going to be traveling in the negative direction, and the black cart, which is going to be traveling in the positive direction. And we're looking for this position of intersection. So to do that, we want to write an equation for that graph. This is at least the way that I'm going to do it. You could put these equations into your calculator also. So the equation for this graph is going to be the final position will be equal to the, we're going to use this y equals mx plus b format, is equal to the slope. All right, well, the slope is equal to the velocity of the object. So we'll come back here and look that the red cart had 0.426. However, that was going forward. Now we have it going in the opposite direction, so we need to have a negative sign. 0.426 times t plus the starting position of the black cart. Well, let's call the starting position of the black cart 0. In fact, let's go back to this diagram. Let's make a number line where that is the origin, and that is 417 centimeters, or 4.17 meters. So that'll be our number line. That means that the starting position of the red cart should be 417 meters. Now, the final position, so this is for the red. Okay, so here's the black. For the black cart, let's grab all this and make sure it's visible. Pull all that down a little bit. For the black cart, we have the slope was 0.125 times t plus a starting position of 0. Now, what we want to do is rearrange all this to solve for the final position. And so we're going to do a little algebra. We're going to do xf minus 4.17 divided by negative 0.426. That will equal t. Whoops, let's make that a t. Oh, okay, that's the way it's going to be. Over here, we can do a similar thing, do algebra to isolate t. And the reason is because we want to solve for x sub f. So we will have x sub f over 0.125 equals t. And because both those things equal t, we can set them equal to each other. X sub f minus 4.17 over negative 0.426 equals x sub f over 0.125. Solving for x sub f gives us equals 0.95 meters. There's a little rounding in that, but not much. And so we should place the collision should have 0.95 meters from the black cart. That's the solution.